Hi guys, in the previous lecture, that is the lecture number 30, we have completed the current commutation. Okay, now in this lecture, that is the lecture number 31, we will start class C commutation, that is also known as impulse commutation or complementary commutation. Okay, so let us move to the first slide. See, this is the circuit arrangement. Here two thyristors are connected like this. In between two thyristors, this capacitor is connected like this, and I am assuming that assumption is Vc of 0 at t is equal to 0, that is equal to supply voltage, means capacitor is charged with polarity like this at t is equal to 0. So what will be the Vc of 0? Vc of 0 will be equal to Vs. This is the first assumption. Second assumption is T2 is on, means this T2 thyristor T2 is on for t less than 0, means this thyristor T2 is conducting. Okay, and T1 is off for t less than 0. Got it? These two are the assumption. Now we have to turn off this thyristor T2 by using the commutation technique, that is the class C commutation. I am considering that T2 is on for t less than 0, and for t less than 0 the voltage drop across this capacitor is like from plus to minus, that is equal to supply voltage, and the capacitor current I am assuming flowing like this. The polarity of capacitor current I am assuming from left to right like this. This is my assumption. Now I have to turn off this thyristor T2. So how will I turn off? See, I have already told you to turn off the SCR. There are two processes. First process is make the voltage polarity across this SCR by using capacitor such that it will go into the reverse blocking mode, means make like this. This is anode and cathode. So when anode is connected to negative polarity of this capacitor voltage and cathode is connected to positive polarity of this capacitor voltage, then this thyristor will be turned off. First method is this. Second method is when you will make, this is, let us say the thyristor is conducting anode with anode current that is equal to I naught. So if I will make anode current less than equal to holding current, then this thyristor will be in off state. So there are two methods of turning off this SCR. Now see which method I am applying in impulse commutation or class C commutation. Let us say in mode 1 I am taking this as a mode 1 where capacitor voltage is equal to Vs for t less than 0 and capacitor current is flowing from left to right. Okay. Now at what I am doing, I am triggering this thyristor T1. Initially T2 is triggered for t less than 0, that is the assumption. T2 is already triggered for t less than 0. So T2 is conducting for t less than 0. Now I have to turn off this thyristor T2. So to turn off this thyristor T2, what I am doing, I am triggering T1 at t is equal to 0. Okay, so the moment when I will trigger this T1 at t is equal to 0, means this T1 will be sorted. Okay, so the moment when this will be sorted, see the voltage drop across this thyristor T2. This thyristor T2 is conducting, this is T2. The moment when I will trigger this thyristor T1, means it will be sorted. So the voltage drop across this thyristor T2 will be somehow like this. Capacitor, let us stretch this point to this point. If you will stretch this point to this point, then the voltage polarity across this thyristor T2 will be from plus to minus like this, means anode is connected to minus and cathode is connected to plus. The moment when the voltage across this thyristor T2 will be negative, means this thyristor will go into the reverse bias and it will turn off. Got it? So now tell me what is the current flowing in this thyristor when T1 will be triggered at t is equal to 0. So the capacitor current, this is the capacitor current, right? So what will be the capacitor current we will need to find, and what will be the total current flowing in thyristor T1 we will find. This is the thyristor T1 IT1. Okay, so IT1 will be equal to, IT1 is equal to, let us say this is IR1 and this is IR2, right? So IT1 will be equal to, this is IT1, so IR1 will flow here like this and IR2 will flow from here to here, because this thyristor will go into the off state. When T1 will be on, this thyristor will go into the off state, so IR2 will flow from R2, then capacitor, and again to T1. So IT1 will be IR1 plus IR2, and we can see that IR2 is flowing opposite to the capacitor current. Is it fine? So I can write like this: IR1 minus IC of T. IR1 can be found by Vs upon R1. IR1 is equal to Vs upon R1 and minus IC of T. So if I will find the capacitor current, then I can easily find the what is the total current flowing in the in the thyristor T1. Okay, so let us find the capacitor current first. So ICT, in order to find the ICT, first we will find Vc of T. So we know that the Vc of T in RC circuit, what is Vc of infinite plus Vc of 0 minus Vc of infinite into e to the power minus t upon tau. I can write like this. What is the Vc of t? So what will be the Vc of infinite? See, Vc of 0 we have already assumed that it is equal to Vs. Now what will be the Vc of infinite? At t is equal to infinite, this T1 is sorted. So this voltage, supply voltage, will charge the capacitor with opposite polarity. See here, this capacitor, this supply voltage will charge the capacitor with opposite polarity of the initial capacitor voltage. So what will the Vc of infinite? Vc of infinite will be minus Vs. So Vc of infinite will equal to minus Vs. It will be minus Vs plus Vc of 0. Vs minus Vc of infinite means it will be plus Vs e to the power minus t upon tau. What is the time constant? See here, time constant is equal to RC. We know that R equivalent into C equivalent. Now see, this RC circuit is separated from this R1. See, this is supply voltage, this is R2, this is capacitor, and again this is supply voltage. So their time constant is only the multiplication of R2 into C. Got it? So time constant will be R2 into C. So finally Vc of t I will get, that is equal to minus Vs plus 2 Vs e to the power minus t upon R2 into C. So what will be the IC of t? IC of t, we know that C dVc t upon dt. So differentiate above equation, it will be C into 2 Vs upon R2C. It will be in minus e to the power minus t upon R2C. Only differentiation you have to do. So finally IC of t will come out to be minus 2 Vs upon R2 e to the power minus t upon R2C. Okay. So what will be the IT1? The current flowing in thyristor 1. IT1 will be equal to Vs upon R1 minus ICT. So it will be plus, ICT is negative, so minus of minus will give plus. It will be 2 Vs upon R2 e to the power minus t upon R2C. So this is the actual thyristor current flowing in thyristor T1. Got it? So we got two equation in mode 1. IT1 is equal to this much and Vc of t is equal to Vs into 2 e to the power minus t upon R2C minus 1. Got it? Thyristor T2 will be off at t is equal to 0 only when T1 will be triggered. When T1 will be triggered, the voltage drop across this thyristor T2 will be negative because of this capacitor. I told you, this is thyristor T2 and this is the capacitor, and the polarity of voltage drop across this capacitor is from minus to plus, and this is anode, this is cathode. So T2 will be turn off at t is equal to 0 only. Now I have to find the circuit turn off time of this T2. What will be the circuit turn off time of this T2? That is equal to TC2. Now we know that circuit turn off time is defined as the time for which the thyristor is in reverse bias. So this thyristor T2 is in reverse bias till the voltage drop across this thyristor T2 will be negative, means this is Vs, right? So when this voltage drop across capacitor will move from minus Vs to 0, then this thyristor, the time taken by this thyristor, we will get, that is equal to circuit turn off time. At t is equal to Tc2, the voltage drop across this capacitor Vc of t will be 0. Then this thyristor, we can find the circuit turn off time, this thyristor. So put Vc of t is equal to 0 and find time. You will get the circuit turn off time, that is equal to 0 is equal to Vs into 2 e to the power minus Tc2 upon R2C minus 1. So find Tc2. Tc2 will come out to be R2C ln2. This is the circuit turn off time of the thyristor T2. Got it? So if I will ask you in mode 1, what is the IT1 peak? Peak thyristor T1 current, that is equal to Vs upon R1 plus 2 Vs upon R2. Okay. And what is the circuit turn off time of T2? TC2 will be R2C ln2. We have already found. So that's the end of mode 1. Now see mode 2. In mode 2, there is, in all the previous commutation we have seen that mode 1 is coming first, mode 2 is coming second, and mode 3 is coming third. But in class C commutation, it is not necessary that mode 1 is coming first or mode 2 is coming second. It is not necessary, because these two are independent. These two modes are independent of each other. In mode 1, what we have assumed, see, in mode 1 we have assumed that Vc of 0 is equal to Vs, and the polarity of Vc is like this, and polarity of capacitor current is like this, and initially T2 is conducting, and we have to turn off this T2. This is the mode 1. Now in mode 2, what we are doing, we are turning on, means T1 is already conducting, and now I have to turn off this T1 by using class C commutation. Okay, so both T1 and T2, the mode 1 and mode 2, are independent of each other. So now see, in mode 2 what we are assuming, that Vc of 0 is equal to Vs, and the polarity of Vc is from minus to plus like this. Okay, this is the assumption, and initially T1 is conducting, means T1 is already conducting for t less than 0, and polarity of Vc, voltage drop across capacitor, is from minus to plus like this, and capacitor current is flowing from right to left. This is my assumption. Now I have to turn off this thyristor T1 with the help of T2, R1 and R2. So both mode 1 and mode 2 are independent of each other. Okay. If I will connect the supply across T2, then it will be mode 1. If I will connect the supply across T1, then it will be mode 2. So both modes are independent of each other. So in mode 2, what we have assumption, that the voltage drop across capacitor is from minus to plus like this, and capacitor current is flowing from right to left. Okay, and initially the voltage drop across capacitor will be Vs, and thyristor T1 is on and T2 is off. In mode 1 it is opposite, thyristor T1 is off and T2 is on for t less than 0. But in mode 2 I am turning on this thyristor for t less than 0, means thyristor T1 is conducting for t less than 0 and T2 is off. Now what we are doing, at t is equal to 0, I am triggering this thyristor T2. Okay, so the moment with this thyristor, I will trigger this thyristor T2. So you can see that the positive plate of this capacitor is connected to cathode of T1. This is T1, no? This is T1. Now when I will trigger this thyristor T2, means it will be shorted. So what is the capacitor voltage? The capacitor voltage polarity will be somehow like this, it is plus and this is minus. So this thyristor T1 will go into the reverse blocking mode, because cathode is connected with plus and anode is connected with minus. So it will go into the reverse blocking mode and it will turn off. Okay, so the moment when T2 will be triggered, thyristor T1 will be off. Okay, so I can say that these two thyristors are working in complementary fashion. That's why class C commutation is known as complementary commutation. Okay, so when I will trigger this T2, then T2 will be on. At that time, what is the current flowing in this thyristor T2? The current flowing in this thyristor T2 will be IT2. Okay, and IT2 I can write like IR1 plus IR2. I can write like this, because see, this thyristor T1 will be off. This is T1. So this thyristor T1 will be off when T2 is triggered. So this is open circuited. So IR1 will flow opposite to the capacitor current, and IR2 will flow like this. IR2 will flow like this. Okay, so what will be the IT2? IT2 will be equal to IR1 plus IR2, and I can write IR1 is equal to minus of IC of t. Minus of IC of t plus IR2 can be written as Vs upon R2. Okay, so if I will find the IC of t, then I can easily find IT2. Okay, now to find the IC of t, what we will do? We will first find the Vc of t. So same procedure can be applied. Vc of t is equal to Vc of infinite plus Vc of 0 minus Vc of infinite e to the power minus t upon tau, and here time constant will be R1 into C, because when T2 will be triggered, then this R1 and this capacitor will make one circuit, that is the RC circuit, and it is connected to the supply. So R1 into C. What will be the Vc of infinite? Vc of infinite will be C. Capacitor is charging with this plate plus and this plate minus, and initially it was from plus to minus, so Vc of infinite will be minus of Vs. So minus of Vs plus Vc of 0 is equal to Vs minus of minus Vs e to the power minus t upon R1C. So finally Ic of t I will get, that is equal to minus 2 Vs upon R1 e to the power minus t upon R1C. Differentiate this Vc of t, Ic of t is equal to C dVc of t dt. You will get Ic of t this much. Same procedure like in mode 1, only the difference is the voltage assumption across capacitor is opposite to the mode 1, as well as current flowing in the capacitor current is opposite to the mode 1. Okay, so finally IT2 I will get, that is equal to Vs upon R2 plus 2 Vs upon R1 e to the power minus t upon R1C. This is the IT2. So what will be the peak current? IT2 peak will be Vs upon R2 plus 2 Vs upon R1. Okay. Now the last point is we have to find the circuit turn off time of T1. Circuit turn off time is defined as the time for which thyristor is in reverse bias. So this thyristor is in reverse bias till when the voltage across this capacitor is negative. This capacitor, the voltage drop across this capacitor is from minus to plus like this. You can see that this minus is connected with anode and this plus is connected with cathode. So when this voltage drop across this capacitor will go from minus Vs to 0, then the time taken by this thyristor in off state will be the circuit turn off time. So I can write like when Vc of t is equal to 0, then the time I will get, that is the circuit turn off time. See, minus Vs to 0. After that this capacitor voltage will be greater than 0, so it will go into the forward blocking mode. So we will not include the forward blocking mode time in circuit turn off time. Got it? So Vc, when Vc of t will be 0, Vc of t I was getting, that is equal to Vs into 2 e to the power minus t upon R1C minus 1. This is the Vc of t, that is equal to 0. So this time will give the circuit turn off time Tc1, that is equal to R1C ln2. Solve this equation, find time t, that is the circuit turn off time. Tc1 is equal to R1C ln2. So in nut and shell, these two modes are independent of each other. There is nothing like that ki mode 1 is coming first and mode 2 is coming second. There is nothing like that. If I will trigger T2 first, then it will be mode 1. If I will trigger T1 first, then it will be mode 2. It is in my hand. So finally I can write the formula that IT1 peak we have already found, that is equal to Vs upon R1 plus 2 Vs upon R2. Similarly IT2 peak will be Vs upon R2 plus 2 Vs upon R1. Circuit turn off time for thyristor T2 is equal to R2C ln2, and circuit turn off time for thyristor T1 is R1C ln2. So here the value of capacitor you will get 2. If you will find the value of capacitance by using this equation, then C is equal to Tc2 by R2 ln2, and if you will find the value of capacitor by using this equation, then C is equal to Tc1 by R1 ln2. So you are getting two value of capacitance. So choose those capacitor whose value is high to make the high circuit turn off time. If capacitor will be high, then the circuit turn off time will be high, and we know that circuit turn off time must be greater than the device turn off time. Okay, for successful commutation. That's why we are making circuit turn off time high. So in order to make the circuit turn off time high, we have to choose those value of capacitance whose value is greater. Okay, and the application of this class C commutation we will be using in CSI and parallel inverter. We will see in the inverter section. So these 4 formula you have to keep in mind in class C commutation. None of the question can be framed apart from this formula. Okay. So that's all about this lecture. In the next lecture we will start voltage commutation. So if you guys understood the concept, then please like this video and subscribe to this channel. For doubt solving, you can join our Facebook group. Thanks for watching this video.